The first section in Chapter 3 is titled Fractions and Decimals. Some vocabulary terms. A terminating decimal is a decimal whose digits end. Every terminating decimal can be written as a fraction. That's important to remember. A repeating decimal is a decimal with a pattern in its digits that repeats without end. And bar notation is a bar or a line that's placed over the digits that repeat in a repeating decimal. So let's look at some examples. You are to write the fraction as a terminating decimal. When you are doing this, some of you maybe have heard the phrase before, tip and divide. But what we're going to do is take the bottom number, 8, and divide it into the top number. So we're going to write ourselves a division problem. And this is going to be longhand, and you'll need to do it on the side of your paper or some side work. We need to see how many times 8 goes into 7. Well, 8 doesn't go into 7 at all. So we put our decimal place before we start adding zeros. That's the first important thing to remember. And I'm just putting a leading 0 in the decimal place on top so I don't forget where my decimal goes. Remember, they always line up. So 8 goes into 70. 8 times 8 is 64. Then we subtract, and we get a remainder of 6. Because this is a terminating decimal, we need to continue adding zeros until the decimal actually terminates, which means we'll have a remainder of 0. 8 goes into 60, 5 times, 7 times, sorry. 8 times 7 is 56. When we subtract, we get a remainder of 4, so we need to bring down another 0. 8 goes into 40 5 times. 8 times 5 is 40 with the remainder of 0. Once you have the remainder of 0, then we've written the fraction as a terminating decimal, 0.875. Let's try it again with 4/5. If you'd like to try this one on your own, remember how to do long division. We are dividing 5 into 4. 5 does not divide into 4, so we need to start adding some zeros. 5 goes into 40 8 times. 8 times 5 is 40. We have a remainder of 0. Once you have the remainder of 0, remember, you have the terminating decimal. So the terminating decimal, 4/5, the fraction, can be written as 0.8. Okay, same type of thing here, but now this is going to be a repeating decimal. So a couple of things are going to change. We have still 5/12, and we want to tip and divide. So how many times does 12 go into 5? Doesn't go into 5 at all, but it does go into 50. So 12 goes into 50 4 times. 4 times 12 is 48. When we subtract, we get a remainder of 2. As long as we have a remainder here, we do need to keep going until the remainder starts to repeat. 2 goes into 20, or excuse me, 12 goes into 20 one time. 1 times 12 is 12. When we subtract, we're left with a remainder 8. A different remainder, so we're going to bring down another 0. 12 goes into 80 6 times. 6 times 12 is 72. When we subtract again, we have a remainder of 8. Now you'll notice if we bring down another 0, this remainder has now repeated. The last remainder we had was an 8. And we brought down a 0 and had 80. Well, here again we have a remainder of 8. So if I bring down a 0, again I'm seeing how many times does 12 go into 8. So what I'm going to see here is that if I were to continue this pattern, these 6's would continue. Once you have the pattern of the repeating decimal, you can stop. And we write the fraction. You only write the part that repeats once. So it's 0.416. We don't have to write all those 6's. And we put the bar, remember the bar notation we talked about, over the 6, because the 6 is the portion of this decimal that repeats. Let's look at another example. Here we have -5/6. We're still going to tip and divide. We're not going to worry about the negative right now, but we need to remember that negative at the end. So how many times does 6 go into 50? Because it doesn't go into 5. So 6 goes into 50 8 times. 8 times 6 is 48. We subtract and have a remainder of 2. Bring down a 0. 6 goes into 20 3 times. 3 times 6 is 18. When we subtract, we again have a remainder of 2. So if we brought down another 0, again 6 into 20. Notice that's what we had just done in the step before. So we would have a bunch of repeating 3's. Remember, as you're writing it as a fraction, you don't have to write all those 3's. You just have to write one of them. 0.83, and the 3 repeats. So we put the bar just over the 3. The last thing you have to remember with this example is that it was a negative fraction, so we need to make our answer negative also. So now let's compare fractions and decimals using less than, greater than, or equal to. We have 1/4 and 0.2. Some of you may know what 1/4 is right away as a decimal, and you don't have to do the tip and divide, but if you're not sure, we need to put both of these numbers in forms that we can compare. They need to be the same. So we are going to tip and divide. 4 goes into 1, it doesn't, but 4 goes into 10 2 times. 2 times 4 is 8. When we subtract, we are left with a remainder of 2. Bring down a 0. 4 times 2, or 4 into 20, 5 times. And when we subtract, a remainder 0. So 1/4, the fraction, can be written as 0.25, the terminating decimal. So now which is bigger, 0.25 or 0.2? You should be saying 0.25. So 1/4, or 0.25, is bigger than 0.2. On example 6, we have negative 5/8 and negative 6/9. These fractions are both negative, and we'll worry about that in a minute, but what we first need to do is tip and divide. So I'm going to do 5 into 8 first, or excuse me, 8 into 5. Okay, so 8 goes into 50, let's see, 4, 5, 6 times. That's 48 with a remainder of 2. Bring down a 0. 8 goes into 20 2 times. That's a 16 with a remainder of 4. 8 goes into 45 times, and then we get a remainder of 0. So the fraction 5/8 can be written as 0.625, but remember it is negative, so it's a negative 0.625. We need to do the same thing with 6/9. So 9 goes into 60 6 times, that's 54. When we subtract, we have 60 again as we bring down a 0. 9 again goes into 66 times. 6 times 9 is 54 with another remainder of 6. So hopefully you can see here this is a repeating decimal. It's 0.6666666, and the 6 repeats. So we would write negative 0.6 repeating. Now we need to compare these two numbers. Be very careful here. Because we are dealing with negatives, remember that the larger absolute value is actually the smaller number because we're negative. So if I wrote some extra 6's on here so that we could compare, we have 0.625 or 0.66. Now 0.66 is bigger, but since it's negative, it's actually smaller. So the fraction negative 5/8 is larger or greater than the negative fraction 6/9. In class, we'll work on worksheet 3.1. What's really important in this lesson is that you are able to do long division correctly.